Let's do some questions in max terms where we are going to use the K-map to solve the problems. These questions I solved in the other way in the last video, so please go look at it if you have some time. Now let's do the max terms question. First of all, we have to come up with the Boolean expression. So how can we do that? First of all, let's write down the max terms. Since we are working with max terms, we have to select output 0. So those are the terms that we are going for. This is M0, this is M1, this is M234, and then we have M6. Now, let's write down the Boolean expression. So we can say f is equals to, first of all, we have 0, 0, 0. So it will be a plus b plus c. And since we are working with max terms, we use the product of sums, POS form. So here we have the sum, then we have the product. Then we will have a plus b plus c bar. Then we will have a bar plus b plus c, a bar plus b plus c. Then we will have finally a bar plus b bar plus c. Now we have come up with the Boolean expression. Now we go to the second step. This is where we are going to plot the K-map. Since this is 3 input system, we are going to use 4:2 map. Now let's write down the directions. We have a plus b and then we have c. And here also we are going to mark down which combinations represent which cells. So this will be a bar plus b bar, and this will be a bar plus b, and this will be a plus b, and finally a plus b bar. And here we have c and c bar. This order depends on gray code. I will attach the link to the K-map video where we discuss about this. You can go through that if you are confused on how to write this order. Now let's mark the combinations. We know M0 is a plus b plus c. So here we'll put the 0. A plus b plus c bar, we'll put a 0 here. A bar b, a bar plus b plus c, a bar plus b plus c. And then finally a bar plus b bar plus c. So here we will have another one. Now the beauty of this is we just need only 2 groups. Now we are going to the simplification process where we group the zeros. Only 2 groups are enough, which will be this one and this one. It's very simple because you have to choose the minimum number of groups and the largest groups possible. Since we don't have any groups of 4, we are going for groups of 2, and only 2 groups are enough to do this. So let's write down the simplified POS. So here we have C, this is in the row direction, so C will come. But here we have a bar plus b bar and a bar plus b. So b bar and b will cancel each other out. So we will get a bar plus c into, here we have a plus b. Since it's the column direction, we will only have a plus b, because c and c bar will cancel each other out. So we will directly go to the logic circuit design. Since we are working with POS, we will use NOR gate. So we have to arrange according to that. So the 4th step, drawing logic circuit by using only NOR gates, since this is max terms and POS. To do that, to arrange the terms, we are going to use De Morgan's law. I will attach a video on how to do that also. So f is equals to, we will use double complement first. Okay, so we will have a bar plus c into a plus b. Now I will break only the lower bar. This is the lower bar. So this will give me a bar plus c whole thing bar plus a plus b whole thing bar. And if you look at the diagram, you will need a bar. So there is one gate, and here we will need another gate, here we will need another gate, and finally here another gate. So there will be 4 gates required. So let's write down all the signals. Let's write down or draw the signals first. Now we need a bar. So let's send a twice through a single NOR gate. So here I have to put dots to show that it is dividing into 2. Then I have to send this through another NOR gate. So I will do that here. Now I have to send A and B through NOR gates. And finally, this output and a bar plus c whole thing bar through another NOR gate. So this is it. We need only 4 NOR gates to do this question. Just to be Clear? I'll mark down what's happening. That's it. So this is the output that we require, and we have done that. Only four no gates are required. You have to show these dots properly, or else people will get confused on where this is originating. Okay, so you have to be very careful with that also. So make sure to put the dots in the proper places. Okay, like this. Now let's go to the second question. Same drill. First of all, we need the max terms. So we have M0, M2, M3, and M4. Did I make a mistake in the first question? No, I did. Okay. Here, the first step is writing the equation. F is equals to A plus B plus C, since we are calculating only zeros. And then A plus B bar plus C. And then A plus B bar plus C bar. And finally, A bar plus B plus C. Second step, we are going to plot. We are going to plot the specific K map. Since there are three inputs, we need 4 by 2 map. A plus B is the direction here. C is the direction here. Not the direction, we are naming the direction. So this will be A bar plus B bar. And then we have A bar plus B. And then A plus B. Finally, A plus B bar. And then we have C and C bar as we normally do. Now let's plot this. A plus B plus C. A plus B bar plus C. A plus B bar plus C bar, and then finally A bar plus B plus C. Now we are going to the third step, simplification, grouping. We need only two groups. Obviously, you can name the groups if you want, but if you don't, it doesn't matter in questions unless they explicitly ask you to name the groups. Okay, so let's simplify this. F will be equals to, this is in the row direction, so C will come. But here A bar, here A, so they will cancel each other out. So we will get B plus C into, here we have A plus B bar, but in the column direction, so we will only have A plus B bar. C and C bar will cancel each other out. Simplified expression is ready. Now we are going to arrange. We are going to the fourth step where we will arrange and then draw the logic circuit with only NOR gates. So F will be equals to double complement of B plus C into A plus B bar. So this will be equals to B plus C whole thing bar plus A plus B bar whole thing bar. That's it. This is it. Now we can draw the logic circuit. So let's draw the ABC input lines first. And now we need B plus C whole thing bar. So we are going to send B and C through a NOR gate. So if you draw like this is also acceptable, but this is not used in standard nowadays. Okay, it's not the standard nowadays. That's why we use that huge dots when we are drawing electronic diagram. See, we have denoted dots with dots here so that it's originating here. This specific line is originating from here. So this is actually A and it is dividing into two. So that's why we have A here and this is C. So here there is no connection. That's the idea. Okay, that's why we use big dots, big colored dots. But if you draw like this, you won't need dots, but this is not the standard nowadays. So that's why we avoid that. But let's do one question with that also. So we will send this through a NOR gate first. And then we have A plus B bar whole thing bar. So we need A and then B bar. For B bar, we know we have to send B twice through NOR gate. It's very simple. Don't complicate this. This is very simple actually. Now we have to send these two through a NOR gate. Finally, these two intermediary outputs will be sent through another NOR gate for final output, which is F. Let me name this for your understanding. Now we have the final answer. That's it. This is how you do this question. And finally, we will go through another question too. And this is the third one. And wow, we don't have A, B, C, and F. So let's put this as A, B, C, and let's name this as X. Output can be named however you like, unless they explicitly ask you to use these input names and these output names. This we will do in the next video, so don't worry. So the first step, we are going to come up with the Boolean expression. So we need the min terms. We have M0 here and M2 here and M3 here. Interesting. So X will be equals to A plus B plus C into A plus B bar plus C into A plus B bar plus C bar. That's it. Now we can simplify this by using K-map. So let's plot the K-map first. Since there are 3 inputs, we need 4 by 2. You can use 2 by 4. I have explained that in this last video, but it's not conventional. So we do the conventional thing. So this will be A plus B, this direction, and this will be C. So we will have A bar plus B bar, and then A bar plus B, and then A plus B, and finally A plus B bar. And we will have C and C bar. A plus B plus C, let's plot here. A plus B bar plus C, so that will come here. And then A plus B bar plus C bar, so that will come where? Here. Now, here also we will need 2 groups, whether we like it or not. Why? All 0 should be covered. I mean, I can go for a 0 here, and then I can just group this one alone. But whenever you can go for a larger group, go for it. Okay, since overlapping is allowed, go for it. So that's the third step, simplification. We have grouped it already. So yeah, let's write down the simplified expression, which will be, since this is in the row direction, C will come, but here we have B and here B bar, so they will cancel each other out. So we'll get A plus C into, and he will have, this is in the column direction and it's A plus B bar, so we will get A plus B bar directly. Why? C and C bar will cancel each other out. That's it. So F will be equals to, I'll just go there directly. So we'll have A plus C whole thing bar plus A plus B bar whole thing bar. Now I can draw this. Here we have the ABC input lines. So we need A and C through a single NOR gate. Let's draw that. And when you are doing with the standard one, make sure to put those big black dots. And then we have A plus B bar. So we need a B bar. So let's do that also. We have to send it twice through a single NOR gate. And there comes the dots or circles. I mean fill circles. And then we have A here again. So let's send A also. Now we have to send these 2 through a NOR gate again. And then these 2 through another NOR gate. That's it. I will name the lines just so that you won't get confused. So anyways, we require 4 NOR gates here also. This is how you do these questions. In the next question, we will be focusing on scenario questions where we will have at least 4 inputs in the questions. So make sure to watch that also. Thank you for watching this video on 3 input logic circuit design by using K-maps and max terms. I hope you enjoyed it and you got to learn something new. I'll see you in the next video. Until then, keep learning and stay curious. So let's draw the ABC input lines first. This is another way of drawing lines, okay, denoting the jumps. So that's what I'm doing here. I'm denoting a jump. That's it. And then B bar and C will be sent through another NOR gate.